One of the big things that geology contributes to the world is energy. 97% of all energy that's used in the earth comes from the ground, and a geologist has to find it. That doesn't matter whether it's coal or natural gas or uranium for nuclear energy or oil and gas. And the big thing is oil and gas, okay? And these are the big industries in the world. They supply huge amounts of energy to people, and energy is the second biggest industry in the world. Lots of money goes into it. Okay, and so what we're going to do today is we're going to talk about oil and gas. And we're going to play a game called the oil game. And you're going to learn how to drill for oil using some basic principles of science. So what I'm going to do is first I'm going to go through some principles, 3 different principles, and once you get those, we're going to apply them to how oil and gas is accumulated. Okay, so the first thing on the 3 principles that we're going to look at density, we're going to look at porosity and permeability, and we're going to look at seismic reflection. Density, basically, you know how heavy things are, okay? It's how much mass per unit volume you have. That's density. And obviously, everybody knows about how dense metal is or how dense a rock is, but fluids and gas also have densities, and based on that density, they're drawn more towards the Earth by gravity. So gravity acts on that mass to pull it down towards the center of the Earth. And if we take a look at a bottle where we put in some water, some oil, and some gas, you'll notice that they always come in the same order. The water goes on the bottom, the oil goes in the middle, and the gas goes on top. And that's the order they will always occur. No matter what I do with this bottle, the order always remains the same. And the reason is that water is denser, oil is in the middle, and gas is the lightest of the 3. And that's why they will always remain in that order. Now, if you think about what's in the ground, obviously the most abundant of these is going to be water. Water is everywhere. Okay, you dig a hole in your backyard, you'll hit water. Whereas oil and gas are a little bit harder to find. And those are the things that are going to be worth the most money. Now, the one thing I want you to notice when we look at something like this is that the oil and gas are always at the top. Okay, they always go to the top. So later on, you're going to learn how to drill for oil. And the one thing you got to keep in mind is that they always go to the top. Now, the next thing we're going to look at is something called porosity and permeability. Well, porosity is basically open space in any material. And any material you can look at has some open space inside of it. Some have more and some have less. So, for example, if you look at a sponge, there's a lot of air space in the sponge. That air space is the porosity. That air space can have water in it as well, but that's the porosity. It's not the sponge itself, it's an open hole. Swiss cheese has porosity, it's got those holes in it. So that's the porosity part. Now, if you take that sponge and you squeeze it, all the water is going to come back out of the sponge, and that is the permeability. The ability to flow from one pore space to the next, that's the permeability. So if you have ever seen bubble wrap, for example. Bubble wrap, those were all little bubbles of plastic encasing air, okay? Now, that means it's got porosity, because all that air space is porosity. But can the air flow from one bubble to the next? No. Not unless you pop it. Once you pop it, then it has some permeability. But until you do, it just has porosity and doesn't have permeability. Now, what we're looking for in rocks is to have both porosity and permeability, or neither. Okay? Rocks can have, as I said, porosity and permeability. And here we have 2 different rock types. Okay? The first rock, the one on the right-hand side, is called sandstone, this tan one. Over here on the left-hand side is shale. The sandstone is kind of basically made up of sand grains that are stuck together. The shale is made out of clays that have all been sedimented down and hardened. Okay, so what we can do is we can decide which one of these has porosity and permeability. So if I take a little bit of water and I put it on the shale, the water just runs right off the shale. Okay, and therefore it has no porosity or permeability. Now, if we do that same test, and we put it on the sandstone, what we'll notice that'll happen is it will run a little bit, but all the water soaks up into the sandstone. Okay, so therefore sandstone has high porosity and permeability, whereas shale has no porosity and permeability. Now, if we were going to take the oil and the gas and the water that we just looked at, and we were going to put them into one of these rocks, which rock would you pick? That's right, you would pick the sandstone. The sandstone can store oil, water, or gas inside of it, and therefore it is what is called a reservoir rock. The word reservoir means to store. So we store those things in here. Okay? And so that is where we would put all of our oil and gas if we were going to accumulate it. However, if we go back and look at this bottle that we just had, we will notice that the gas is held up at the top. Now, so what would happen if we pulled the cap off of this bottle? Well, that's right. All the gas would escape into the atmosphere and wind up in the room rather than inside of this bottle. So therefore, the cap is what's holding it in. Okay? Now, the same thing happens with oil and gas accumulations. So we may be able to put all the oil and gas inside of this reservoir rock, the sandstone, but if we don't seal it in, it's going to all escape. So what we need is a cap rock, the shale. So the shale acts like a piece of saran wrap, just covers over that reservoir rock, seals it in, and therefore that will keep your oil and gas from escaping out of that sandstone, out of that reservoir, and therefore you can drill it and produce it. Now, in order to drill wells, and you know, there's been a lot of things on television where you can see people drilling for well, coming up with oil. For example, if you've ever watched the Beverly Hillbillies, they made a movie out of it, used to be an old TV show. The guy goes in the backyard shooting at a rabbit, misses the rabbit, and all this oil comes squirting out of the ground. Okay, well, that's not quite the way it works anymore. And you could get some oil and gas coming to the ground. The La Brea tar pits are actually oil seeping to the surface. But in general, the shallowest you need to drill a well is about a mile down to get oil or gas. A mile. And so I don't think you can find too many shotguns that can reach a mile down into the earth. So you have to drill. And drilling's not an easy thing. It takes a lot of engineering. It takes a lot of time. You're drilling through rock. It costs a lot of money to be able to drill a well. So you kind of want to know where you're going before you start drilling. And the way you do that is a little technique called seismic reflection. Okay? Seismic reflection is something that's been around a long time, about 6 decades, but we actually use something like that now that you've seen. And so if a woman is going to have a baby and she wants to go to the doctor and to make sure the baby is safe and healthy and everything else, they perform on it what is called an ultrasound. Okay, and everybody's probably heard of that, produce a sonogram. And how that works is you put a device on the woman's stomach and it shoots out high-frequency sound waves that penetrate through the skin, penetrate everything, hit the surface of the baby, and bounce back up towards that device, which also has a receiver on it. Once the receiver gets the waves coming back off that have bounced off, it can then image what the baby looks like. Okay, and that's the way the ultrasound works. Ultra-high sound waves bouncing off of the baby coming back up to the surface. Well, they've been able to see what's underground doing that for many years now. 6 decades they've been doing that in the oil business. It is basically generating a wave by some method. The wave hits an interface between 2 different rock types, bounces back up to the surface. And you can image way down 10, 15 miles deep to see what the shape of the strata are underground. Okay? And so that is how then we can kind of see what things look like underground before we drill a well to them. So maybe we can see what we might want to drill at rather than just drilling blindly. Okay, now we have a little device here that I put together so people can see what seismic reflection looks like. And what you can see here is a box, and it is made out of plexiglass shelves. Okay, so you can see all these, you see it's plexiglass on the top, but I'll tell you now that there's a bunch of shelves underneath there. And I can say to you, how many shelves are there? And you can say, you can take a guess, or maybe if you look on the side, you can see. But otherwise, how are we going to tell otherwise without pulling this apart to see how many shelves are, which is a pain in the neck. Pull it apart to put it back together again. What we can do is we can take a little laser pointer and we can just turn that on, and you will see that all the dots come up on the back, and you can count them, and you can see there's 4 dots, which means there are 4 shelves. Now what's happening is that the laser is hitting each one of those shelves, reflecting off of there, and the little dot is coming up to the surface. Okay, so with that, without even pulling it apart, I know how many shelves are there. Now if I'm careful to slide it across, I can even see what shape those shelves are. So you can see that the top 3 are pretty much flat. But look at what that bottom one is doing. That's tilted. So with this, I can see the shape of the shelves, and I can see how many there are. So this is giving me some idea of what's underground without having to actually dig a hole to it. So here are our 3 things that we have put together then to help define our different types of oil accumulations. We're going to use all 3 of them now. We're going to put them together, and we're going to find out what are called oil and gas traps. Okay? So we're going to use the density, porosity and permeability, and seismic reflection all together to define oil and gas traps. Okay? These are pictures of oil and gas traps, okay? And we'll start off with, and that's what an accumulation is called, a trap, okay? And so what we'll start off with is what is called a stratigraphic trap. And this on this side is a stratigraphic trap. This is a block diagram. The green part is the surface of the Earth. Everything else is looking down into the Earth, okay? So these are cuts down into the Earth. Now if you look, you will see a wedge-shaped area on the first one, on this stratigraphic trap, and it is encased in brown. Okay, now the brown is caprock, and the wedge-shaped area is reservoir rock. So in order to tell what shape it is underground from the surface without having to dig down there, and digging would be a very costly thing, we would use seismic reflection. So the seismic reflection will tell us that there is a wedge-shaped body underground. We know, so that's the first thing we're using. The next thing we're using is that we know that the brown is caprock and the wedge-shaped body is reservoir rock. So that's the second stuff that we talked about. Now, if you look inside of there, you'll notice that it's white on top, black in the middle, and gray on the bottom. White is gas, black is oil, and gray is water. So it's in the same order that we talked about for our density. So all 3 are applied to this feature. Okay, so that's the first one. Second one, we can over and look at this, which is called an anticline trap. Now, when 2 continents smash into each other, or a lot of other ways too, rocks can actually be folded. Okay, and they can fold down into a U shape, or they can fold up into an arch shape. And an arch-shaped fold is what is called an anticline trap. Okay, and so this is a picture of an anticline trap. You can see again, surface is green, and we can see underground the brown is the caprock. The one underneath the caprock is our reservoir rock, and once again we can see gas, oil, water in the same order. So therefore we can see that both of these are taking all 3 of our concepts and putting them together to make oil and gas traps. Okay? And if we look at both of these and kind of stand back and look at them, we will see that the oil and gas in both examples sits right at the top of the structure. So as I said, always drill high, always drill at the highest point, and you can see clearly that that's exactly where you need to go on any feature that's geological. Okay, we have a couple other types of traps here. Down on the bottom is what is called a fault trap. Okay, and a fault, not only does it produce earthquakes, but it can also offset layers. So you can have a continuous layer of reservoir rock that then is cut by the fault and then placed up against, shoved up against caprock. And that will encase it in caprock and allow you to accumulate gas on the top, oil in the middle, water on the bottom. Okay, so that's another type. Last type is what is called a salt dome trap. Now in some areas of the world where we have very high evaporation, hot temperatures, where a little sea might be cut off from the main ocean, you can get conditions of what are called hypersalinity. Get huge amounts of salt accumulating in these things, and the salt can actually deposit on the floor of the ocean. So you get salt depositing, it can be quite thick, on the floor of the ocean. Now, later on, once you add clay and sand on top of the salt then turns very squishy. And it kind of acts like toothpaste. And it's very light. And so you squish it down with that sand and clay, and it can squirt back up to the surface in what is called a salt diapir or a salt dome. Okay, and these salt diapirs or salt domes are where we get our table salt from, or even our road salt. They mine these. Okay, but the other thing they do is if you have layers of trap rock or cap rock on top of reservoir rock, they can bend everything up and you can get big accumulations of oil and gas around them. And if you get these big accumulations, these can be worth a lot of money. We get most of our oil and gas in the United States from the Gulf of Mexico. And in the Gulf of Mexico, the big plays are these salt domes. A single salt dome can have 2.5 to 3 billion barrels of oil. Last year, oil was selling for $100 a barrel. So that's $300 billion a single salt dome can be worth. That's more than most companies in the United States, okay? More than a lot of countries. So that's how much things are worth if you can find the right trap and drill it, okay? So that is the background material then for this oil game, okay? And this is the oil game, okay? And you can see it's a box. And if you look at the box, it will have a grid on the top of the box. Now what we're going to do is we're going to divide up the class into groups of 4, 5, 6 students, and each one of you is going to become an oil company. Okay? And we're going to see how well you learn this stuff, so to see whether you can drill and find oil. Okay? And so first thing we're going to do then is each of you is going to be an oil company. You're all chief executive officers of the oil executive officers. You get to make all the decisions. Everybody makes a decision. And each one of you is going to have a model of this box sitting at your table. So here's the model box that you're going to have at your table. And when you look at it, you will notice that there is a grid pattern on the top. Okay? And the grid pattern on the top goes from 1 to 28 and A through Q. Okay, so therefore there are intersections of each of these lines, and the intersection on each one is a potential place to drill an oil or drill a well. Now each of your companies is going to get $5 million to start. Okay, and what you're going to do with that $5 million is you're going to decide how to spend it. And what you can do is drill a well. Okay, and here's a derrick. These are the old-fashioned oil derricks, and I can pick any spot and stick it down there and say, I want to drill right there. Now, what's going to happen if you drill right there? Maybe I'll drill right there. Okay, what's going to happen if you drill right there? So the first thing that can happen is that. And that means you've just spent $1 million to drill a well, one of your $5 million, and if you don't hit something, you're out of that money. That money's gone, and you got $4 million left after the first one. Okay, and I will tell you right now that 3/4 of those intersections on the top, 3/4 of the possible spots are dry holes, and you're going to hit nothing. Okay, and so therefore you've got a 75% chance by picking randomly to hit a dry hole. Okay, now suppose you hit a better spot than that. Suppose you got a decent spot to drill. $2.5 million. So for your $1 million investment, you got $2.5 million back. Suppose you find even a better spot, $5 million. Suppose you find a really good spot, $7.5 million. And suppose you find a great spot, $10 million. Okay, so that's what you will get if you've hit the right spots. Now, as I said, how are you going to tell from this box what you can drill? Okay, well, in addition to spending money on drilling wells, which is the ultimate game, you know, you want to get as much money back as you can. One who wins makes the most money. Got to be the best oil game. But you can spend money on other things. And you'll notice, though, in this box is that the front panel has a bunch of knobs on it, and that can pull away. I'm not going to show you what's under there, but underneath there is a picture, okay, and that's a seismic reflection line. So this is the Earth's surface, and we can look down into the planet and see what's underneath the ground. And then maybe if we find something that looks like what we want, we can think about drilling it. You'll notice that on your box, you have these Velcro tabs on it, and you will get a picture that sticks right to the box once you buy that side. How much is it going to cost you to see that side? $1 million. So each one of these sides you can take a look at for $1 million a piece. Okay, now, as we said, with seismic reflection, you can't tell what the different rock types are. So what you need to buy then, if you want to know, they're just going to have colors. They're going to have layers, and they're going to have, you know, the different features that we just looked at. But you're not going to know what each thing is. It's not going to tell you which is a trap rock or a reservoir rock or any of the other stuff. It's just going to have colors. So if you want to know what the colors mean, it's going to cost you $500,000. So $500,000 to know what the colors are, $1 million for each side, and $1 million to drill a well. That is what it's going to cost. Now, you as a company, you're going to have to decide, should I buy data? How much data should I buy? Should I drill? And you have to budget yourself in addition to knowing the geology to be able to drill. Okay, a couple of rules we're going to play when we do this game. The first rule is everybody in the company has to agree on the decision before you come up here and do something, okay? Second rule is, when you come up, everybody comes up and you bring your box with you, okay? So that's the second rule. Third rule is you are only allowed to do one thing per visit up here. So we're going to go around the room. Each group gets to do it. You're only allowed to do one thing. So you can drill a well or buy data. You can't do both. Got to wait till the next turn. Okay? The next rule is once a well is drilled, it's empty. So if you listen real close and hear somebody says, oh, I drilled A1, hit $10 million. A1 is now off the board. You can't use that anymore. So you can only pick other areas. So you kind of want to think about what you want to drill before you come up here. So what the big idea is then, what the basic idea is, you're going to buy some data. So if you see like a seismic reflection line, you buy it, then you're going to take it, you're going to compare it to what the traps are that we just talked about, and then limit your areas as to where you want to drill. You'll see the numbers will correspond directly above with what you want to do on one side, on the long direction, and letters will correspond to what you want over the shorter orientations. So you put the two of them together, and then you can figure out where you might want to drill a well. So that is the way we're going to play the game. Good luck to you. Find oil.